Why, hello there. Sorry. Hello there, my students. Hopefully this video will explain the things that you didn't do so well on your quiz the other day, and we can use it to help us study for your test coming up in a couple of days. So let's jump right into this. How many times is x minus 1 a factor? Okay, so this is just a synthetic division problem. We're going to synthetically divide with 1. So first we solve that factor, and then we have to use our synthetic division. So there's 1x to the fourth, there's 0x cubed, there's minus 6x squared, so there's an 8, and there's a minus 3. Okay, and we're going to do synthetic division with 1 as many times as we get a remainder of 0, right? We're looking for a remainder of 0. And sure enough, we get a first time a remainder of 0. So then we try again with these 4 numbers now. Okay, so we're using something that we just got to get another 0. Okay, and then we'll try it again with these 3 numbers, and we keep trying it with these numbers. Nope, that's not 3. 2 plus 1 is 3. 0, there's another 0. So then we're going to try it with these numbers again. So now I have a 1 and a 3, right? So I have 1, 2, 3 zeros so far, and then I don't get a fourth 0, which means x minus 1 is a factor of that g function 3 times, right? But have a multiplicity of 3. So you use synthetic division and you see how many times you get a 0. Okay, so be careful with your synthetic division. Which of the following statements are true? X minus 2 is a factor. Okay, if x minus 2 is a factor, that means 2 should give me a remainder of 0 when I synthetically divide. Okay, so once again, this is a synthetic division question. Minus 1, minus 2, minus 6, minus 12, 0. Sure enough, x minus 2 is a factor because I get 0 as a remainder. The graph crosses the x-axis at -2. Well, if the graph crosses, that means we have a multiplicity of 1. Okay, and I haven't checked for multiplicity yet, so let's go ahead and do that and see if it's only a factor once. So just like up above, we're going to use synthetic division again. And we're going to see if I get, what do I need to get here? A remainder of 0, right? So that's this is a 4. 2 times 2 is 4. So a 3, and then I get a 6, and I get a second 0. Okay, so we know that if it has a 2 zeros, that is going to have a multiplicity of 2, and it's going to not cross but bounce. Let's try it again to see if it will flatten. 4, nope, so it does not, which means it bounces. It has a multiplicity of 2, so it does not cross. It will bounce on the x-axis at x equals 2. So 2 is not true. Okay, and then -3/2. So this one might be annoying, but we're going to have to use synthetic division with -3/2. Okay, and figure out if we're going to have a remainder of 0 or not. Okay, -3/2. So let's see what we get. Sure enough, we have a remainder of 0, so which means -3/2 is a root. So my correct answer is D, 1 and 3. 2 is not true because it does not cross at the x-axis, it bounces. Okay, number 3, here we have some algebra thrown in, so we're going to once again do synthetic division, okay, with a 3 on the outside, right, because x minus 3 equals 0. So x equals 3 becomes your divisor. So we have a 3, we have a minus 10, we have a 1x, and we have a k. Okay, and if it's a factor, that means our remainder over here should be equal to 0. Okay, if it's a factor, the remainder is 0. So let's see what we get here. Minus 1, minus 3, minus 2, minus 6. So this is a k minus 6, right? When I add k to minus 6, I get an equation, k minus 6 equals 0. So solving for k means k has to be 6 in order for x minus 3 to be a factor. Okay, this one says if x plus 1 is a factor, okay, so we're going to use synthetic division on our unfactorable, right, third degree polynomial here. and I'm going to get a quadratic as my answer. Okay, so we got to understand that I'm getting a quadratic. Minus 14, positive 14, positive 8, minus 8, 0, right? Exactly what we were expecting. So then these three numbers here turn out to be the quadratic 3x squared minus 14x plus 8. Okay, and we're going to have to factor that. So there's lots of ways to do it. One way is to do the AC, right? The AC method. So we're looking for numbers 3 times 8 is 24. Numbers that multiply to give you 24 and add to give 14, and I'm just going to say they are negative 2 and negative 12. Right? Negative 2 and negative 12 add to negative 14. Okay, so one way we can do this is by changing your negative 14 into minus 12 and a minus 2. Okay, because now we're going to factor it by grouping. So this is one way that we can factor this leading coefficient. So these terms both have a 3 and an x. Right, both of these terms, 3x and 12x, have a 3 and an x minus 4. And these other terms have a minus 2 in common, so that's x minus 4. Okay, so then your x minus 4's get together, and then your 3x minus 2 gets together. And those are your other factors, 3x minus 2 and x minus 4. Okay, there are lots of ways to factor quadratics. That happens to be one method of factoring a quadratic. Okay, so maybe you need to practice that, I don't know. But it's a pretty good idea to have that as a skill. So let's see what's going on next. Which of the following statements is false? We're looking for a false statement. The multiplicity of root x equals 2 is 2. Nope, that's true. It bounces here. So every time the graph bounces, it has a multiplicity of true. That's multiplicity of 2. That's true. It's a cubic function. This one has a multiplicity of 1 because it crosses. So the sum of your multiplicities, 1 plus 2 is 3. Cubic means x cubed, so that's true. As x goes to negative infinity, so this is the left side of the graph, the arrow is pointing up, right? If f of x goes to infinity, that means your arrow is pointing up. And it looks like my arrow is pointing down, so it looks like C would be a false statement. As x goes to infinity, that's the right side of the graph, the arrow points up. Well, that's true. And the domain is all reals. That's true for all polynomials. So sure enough, C is the one that is false. C is false. Okay, number 6. Which of the following is values for greater than 0? So not equal to 0. Everywhere the graph is above the x-axis. Okay, so that happens here all the way to negative 4. And at negative 4, it's equal to 0, so we're going to exclude negative 4 from your answer because it equals 0 there. And then it's above all the way to negative 1. And then it's above again between 2 and 5. So we're going to have 3 intervals excluding negative 4. So it looks like C is going to be the correct answer. Okay, because it says greater than, we're going to have parentheses. When it says or equal to, then we can have brackets, which is exactly what's going on in number 7. We want to know when is it less than or equal to. So now we're looking for where is the graph below your x-axis. And you're saying, wait a second, Manchester, I don't see a graph there. True, but we can use what we know about polynomials to make a graph. Okay, we know that it crosses at positive 2, right, from that 0. We know that it crosses at negative 1 from this factor. And we know that it crosses at negative 3 from that factor. There's one of the bells. We have 10 minutes till class starts. We're good. Okay, so we know those 3 things. Now, what else do we know? Has a multiplicity of 2 and 1 and 1. So this is a 4th degree or an even polynomial. So both of your arrows should be pointing up on the ends. Right, because it's positive, we don't see a negative in front of our parentheses there. So it's a positive 4th degree, a positive even polynomial. We know that it's going to cross at -3 because it has no power. It's going to cross at -1. It has no power, and it's going to bounce at +2 because there is a power. Okay, so we can sketch the graph going down through -3, coming back up through -1, and then going down to bounce at +2. Okay, so now we've made our own graph from what we know about polynomial end behavior. So in between -3 and -1, and I'm using brackets because it says or equal to. So it's equal to 0 at -3 and it's equal to 0 at -1. So we have brackets around both of those things. Okay, so that's either B or D. And then it says, oh, it's also equal to or it touches 0 right there at +2. So there are two places, one place where it's less than, right below the axis, and then one place where it's equal to. So the best answer for number 7 would be D, because x equals 2 is where it's equal. Right here, the graph touches the x-axis, so it's 0. The y value is 0 here. Okay, so hopefully that helps and has cleared up some things for you, and you'll be better prepared for your test soon. Okay, bye.